Blowing through rapid pneumatic depressurization is one of the powerful cleaning methods. Blowing uses compressed air or nitrogen to forcefully remove debris from pipelines. By harnessing the stored energy in a pressurized system, it creates a shock wave that effectively pushes contaminants toward the exhaust end. Let's dive into how it works and its key considerations. When performing blowing through rapid pneumatic depressurization, there are a few critical safety and procedural considerations to keep in mind. Never blow directly into a vessel. Vessels can act as knockout pots, trapping debris that may require costly confined space entry for removal. Additionally, large debris could damage the vessel. For tube heat exchangers, blowing alone may not remove trapped debris effectively. Always inspect the unit prior to installation, and blow each tube individually to ensure it's free of debris and water contamination. Anchor exhaust pipework securely to prevent whiplash during depressurization. Install warning notices, cordon off hazardous areas, and use whip arresters if necessary to manage safety risks. These precautions help ensure the process is safe, effective, and minimizes risks to equipment and personnel. Now, let's go through the key steps in the procedure for rapidly depressurizing a line. If possible, fit a full-bore plug or ball valve at the exhaust end of the pipeline. Pressurize the system to the agreed pressure level. Once pressurized, isolate the energy source to ensure controlled depressurization. Rapidly open the exhaust valve to create a shock wave that pushes debris forward. Repeat the pressurization and blowing process until the exhaust gas is visibly free of dust and debris. Let's discuss the important considerations for instrument airlines during the blowing process. Ensure that pneumatically driven instruments are disconnected from the air supply until all instrument airlines are thoroughly blown clean of debris. Failure to clean the instrument air pipework properly can result in damage to delicate instruments, leading to costly delays in project schedules. During the final stage of cleaning, use a white rag or card at the exhaust to confirm that the air exiting the system is clean and free from debris. If a valve arrangement is unsuitable, consider using a flimsy diaphragm or strong paper disc clamped between flanges at the exhaust point. This method should only be used as a last resort, especially if the pipeline design pressures are not readily available. Here, we see an alternative depressurization method using a strong paper disc clamped between flanges at the exhaust point. As the system is pressurized, the paper disc temporarily holds the pressure until it ruptures, creating a controlled release of air that expels debris from the pipeline. This method is particularly useful when a valve arrangement is unavailable, though it should only be used as a last resort. Notice how the debris is forcefully ejected, demonstrating the effectiveness of this cleaning technique. For monitoring debris, utilize a target plate, such as a 1-inch square bar, positioned in the first section of the exhaust pipe. The plate will show signs of debris through pitting on its surface, providing a clear indication of the cleaning effectiveness. Here, we see a test target plate used during steam blowing. This technique works similarly for blowing with air or nitrogen. The target plate is positioned at the exhaust to monitor debris removal. As the steam, or air or nitrogen, flows through the pipeline, debris impacts the plate, leaving visible pitting marks. These marks provide a clear indication of the effectiveness of the cleaning process, ensuring the pipeline is free of contaminants before commissioning. This is a critical step in verifying system cleanliness and readiness for operation. When conducting pneumatic blows, consider these important guidelines. Perform the process outside normal working hours to reduce noise disruptions and ensure better control of personnel movement in the area. Verify that the air or gas source is clean, dry, and oil-free. If an existing system is used, install a restrictor orifice to limit flow and prevent disruptions to other users. At the exhaust end, if debris cannot be contained with a protective screen, fit a collection pot to safely capture expelled material.